Hello friends, in this lecture we'll apply Cauchy's mean value theorem, or other name is second mean value theorem, to solve problems based on it. Let me revise the statement of the theorem. Let fx and gx be two functions which are well defined in the closed interval AB, and both the function are continuous in the in the closed interval AB, and both the function are differentiable in the open interval AB, and the quotient g dash, second function g dash, which will be the denominator. Gx is not equal to 0 at any point in the open interval AB. Then there is a point C belonging to the open interval AB, such that the chord joining the endpoints is parallel to the tangent at the point. This is a Cauchy deals with the two functions, so the function is in parametric form. Function should be in parametric form. So while calculating the problem, this is we write x or t. The value of the independent variable, whether write x or t or u or v, it depend differential or integral or whatever thing, will not depend upon the variable, but depend on the behavior of the function. So we can write x or t or u or v, whatever we can write, f of x or f of t or f of u or f of v, where you can write anything. But it is the behavior function which counts, not the independent the independent variable. Verify Cauchy mean value theorem for the function fx is equal to log of x and gx is equal to 1 upon x in the closed interval 1 to e. Now, let us first, given is fx is equal to log of x, gx is equal to 1 upon x. So differential of fx is equal to 1 upon x, differential gx is equal to differential of gx is equal to 1 minus 1 upon x squared. This is equal to minus 1 upon x squared. Now the other function 1 upon x square. This is this function. If you differentiate the function fx, now this is a new function. This function, domain this function is equal to all real number except 0, and domain this function is equal to all real number except 0. Both the function means both the function fx and gx are well defined this interval. Domain this function is equal to positive real number. Domain this function is all real number except 0. So the both functions are well defined this interval, and the both functions are continuous this interval. And if you differentiate them, so this way they are different functions. Both the functions are differentiable in the open interval 1. Now let's discuss the same thing. Now fx and gx are two functions well defined. You know well defined. How well defined? I told you that the domain function are function utility is from all except 0. So both this interval 0 to e closed interval is subset of both the intervals. So both the function defined like this. So both the functions are well defined. This means both the functions are continuous and derivative function they exist in this interval. So therefore both the function are continuous. Interval 1 to e closed interval. Both the function are differentiable in the open 1 to e, and g dash g dash x is not equal to 0 for any x. G dash is not equal to 0. It's not 0 because it is 0. It is closed, but it is undefined at x is 0. So 0 is not included in this interval. So this is g dash x is not equal to 0 for any point along this open interval 1 to e. Then, therefore, fx and gx, both the functions satisfy all the condition of Cauchy mean theorem or second mean value theorem in the closed interval 1 to e. Therefore, there exists a real number c belonging to the open interval 1 to e, such that f dash c upon g dash c is equal to f e minus f1 upon g e minus g1. Now substitute the function here for the derivative function. Substitute them. fx is equal to fx and value of fx and fc and gc from here. 1 upon c minus 1 upon c square, and f of e and f of 1, g of e and g of 1 from these functions here, and we got this. So log of e minus log of 1 upon 1 upon e minus 1 is equal to 1 upon c minus 1 upon c square. Now simplify it for a upon b upon c upon d. After simplification, we got it log of 1 is equal to 0, log of e is equal to 1, and 1 upon e. Simplify that, we got c is equal to e upon e minus c. Let us see. Now we have to check whether this belongs to this. Now we have to check it. We're checking c is equal to this. So c minus 1. C minus 1 is equal to e minus 1 is greater than 0. C minus 1 is greater than 0. And e minus c is greater than 0. So make this point belongs to this interval. C minus 1 is greater than 0. This means if it's negative, this point is belongs to this. So this is a method how to check whether this point belongs to this. And the Cauchy mean value theorem is satisfied for the theorem. Now, second question is verify Cauchy mean value theorem for the function f(x) equal to cos of x and g to sin x in the interval minus pi by 4 to pi by 4 is closing. Given function are x equal to cos x, gx equal to sin x. Similarly, differentiate them. This is equal to minus sin x, dx of cos x minus sin x, dx of sin x equal to cos x. Now, both the function, what dominant is cos x for the number? Because the dominant is gx for the numbers. So, and the differential function, differential for fx is a minus sin x. This is only number, this is a real number. Means this both function are well defined this interval, close interval. Both the function are nowhere undefined this interval. Therefore, both the function are found in this interval, and both the function because the domain of the fx they exist. So both the function are different differentiable in the open interval AB. And g dash x is not equal to 0. G dash x is not equal to 0 in this open in the open interval minus pi equal to pi by 4. Therefore, fx and gx satisfy all three conditions of Cauchy mean value theorem in this interval minus pi close interval minus pi equal to pi by 4. Therefore, this one real number c belonging to the open interval minus pi by 4 to pi by 4 such that f of pi by 4 minus f of minus pi by 4 g of pi by 4 minus g of minus pi by 4 is equal to f dash c dx. Now, substitute the value from this f pi by 4 is equal to this function. Substitute values here and simplify them. F pi by 4 is equal to f dash c is a tangent equal to tangent. Now, substitute value is equal to this become cos pi by 4 minus cos pi by 4. Cos of minus theta equal to cos theta. This is 0. 0 can number to 0. So, tan of c is equal to 0. Tan c will be 0 at 0, pi, 2 pi, 3 pi, and minus pi. So, out of these values, only 0 belongs to this interval. So, 0 belongs to this interval, at which the tangent will be parallel to the chord joining the point at the minus pi 2 and minus pi 4, and who gives the minus pi 4 pi. That's a use Cauchy mean value theorem to evaluate the limit x equals to 0 of cos of pi x by 2 upon log of x. Now here we have to apply Cauchy theorem, so we have to split them into two functions. Let fx is equal to this function and gx is this. Gx is equal to log of x. It's not 1 upon gx. This is x is equal to fx is equal to cos pi by 2 and gx is equal to log of x. Now the interval is x greater than 0 and x greater than 0 and b is equal to 1. A is x 1. The interval is for x to 1. Differentiate this fx and gx similarly. F and gx. So fx is equal to minus pi by 2 cos minus sine. This will be sine pi by 2. Gx of 1. Now both the function. What do this function? All the numbers. Where is the function? Now here that you have to decide the interval. This interval. Let me note down this step. A to x to 1. This come you will learn it from your practice. So now the interval is x to 1. Domain is function ordinary number. Domain is function real number. Domain of this function is ordinary number. And domain of function is ordinary number except. So from 1 to x, x is equal to 0. 1 to x, all this both the function well defined. Both the function coordinates therefore, and derivative exists in this interval. Therefore, this function exists in therefore the both functions are differentiable in the interval x to 1. And in the x equal x to 1, g dash x is not equal to 0 because x is 0, 0 is not included in this interval. X is equal to 0. So the fx and gx satisfy both the condition of Cauchy mean all the conditions of Cauchy mean theorem. Therefore, there is a point C belongs to the open interval x to 1 such that f1 fb minus f1 minus fx upon g1 minus gx is equal to f dash g upon g dash. Substitute the value. F1 is equal to how much? Substitute 1. X is equal to 1 here. It's 5 over 4. Fx upon g1 minus log of 1 minus log of x is equal to derivative. Now cos pi out 0, log of 1 is 0, is equal to minus cos of pi x by 2 upon log of 1 minus log of x, log of 1 by x. We don't substitute the value there, we convert that into the form, required form, this required form. So this is equal to become minus 5 by 2 c sine of c, this is sine of c, this is sine of this will be sine of x, this will be sine of c. C is here. This is C. This is again C here. This is again C here. So as x approaches to x less than C less than 3, as x approaches to 1, C also goes to 1. So the x approaches to 1 is equal to C approaches to 1. This is again C. So this will become equal to C approaches to 1. This approaches to 1. This will equal to pi. So this discuss the applicability of the Cauchy mean theorem for the following function: fx is equal to x square and gx to x cube in the interval minus 1 to 1. And this is the function f is 1 if x is less than equal to x less than b, and 2 at b. Gx is equal to 2x if a is less than x and b. Now again fx in the interval minus 1 to 1. Fx this, gx is this. Fx is 2x, gx square. Domain function is ordinary number, domain function is ordinary number, domain function is ordinary number, domain function is ordinary number. So both the functions are well defined in the closed into minus 1 to 1. Therefore, if well defined, both the functions are continuous in the closed minus 1 to 1. Both the functions are differentiable in the minus 1 to 1. And g dash x is 0 at x is 0. So x belongs to this. G dash is 0 at x is 0. So this belongs to the interval. Therefore, third condition is not satisfied. Therefore, we can't apply this Cauchy mean theorem to find Cauchy mean theorem to. Therefore, this fx and gx will not both the function will not satisfy the Cauchy mean theorem in the interval minus 1 to. Expression is here fx is equal to 1 if 1 is less than x is to b, 2 if x is to b, and gx is equal to x. Now what is this? From the problem we come to know that x is equal to b, x is equal to not 2, x to b is a doubtful point. X is equal to b is a doubtful point of continuity of the function fx. Fx, which is a split function of x. Now the fx will be continuous at x equal to x is equal to b, x is equal to b, and fb from negative, fb from negative is equal to f of b b from positive. So this is equal to what value of this? F b from negative is equal to 1, and f of b is equal to 2. So left limit is not equal to, not continuous. Not continuous. And fb from right we can't find out. Cannot discuss. Cannot discuss. Therefore, left limit is not equal to the function. So at 2, the limit does not exist at 2. Left hand limit is not equal to value function at that point. And right limit does not exist. So f is not differentiable at the x is equal to b. X is equal to b, not differentiable. Hence, theorem is not valid.